We don't have class today, and it looks like we probably won't have class tomorrow. My other colleges canceled class today and tomorrow. So, just for those on Friday, be aware that that may be canceled as well. So, I wanted to go over this as best I can. It's a little uncomfortable speaking to my computer and not to you. So, forgive any errors or starts and stops I might make. It's just because it's new to me. I've done this one other time. So we are starting chapter 28. It will behoove you to read the chapter, at least review it along with the slides. There'll be a Kahoot. I will post as soon as I'm finished with this and post this that you can participate in. I will send you the link on Canvas, and that will be your participation for today. Hey, online participation. So I'm sorry, I love this joke, right? Hopefully you get a laugh out of it. That's sincerely my hope. Um, Reproduction can be fun, as we all know. Anyway, next slide. So, what is reproduction? Officially, physiologically, anatomically, it's a process in which organisms produce offspring. And they do so by means of the gametes or germ cells. That would be the sperm and the egg. We have the organs of reproduction. You have the gonads, the ducts that are all the transport mechanisms, storage, things like that, and the accessory sex glands. And those help support and allow for the gametes to mature. And we'll go through all of these situations. Okay, here is an entire view of the male reproductive system. And we're actually going to touch on every single one of these items throughout this lecture. So don't become overwhelmed by this view at the moment. Remember, it's more laboratory, it's more anatomical, but you're still responsible for it in both lecture and lab. Okay, let's start with the scrotum. Its main function, role, and what it is. It's basically just an outpouching of skin from the abdomen that supports and holds the testes. And the reason that this is included in the male reproductive system is for regulation of temperature. So the main regulator of temp is the cremaster muscle, which is right here, and then the muscle right there. Kind of dig in the drawing. Um, so that muscle actually will contract and elevate when it's too cold outside. So the testes will become closer to the pelvic cavity and become warmer. When it's too warm, the cremaster muscle will relax and the testes will move further away from that really warm pelvic cavity. So let's move on to the testes. There's two of them. They're paired, oval shaped. Call them the gonads, right? This is where creation and development of sperm occur. During embryonic period in males, they actually start out in the abdominal wall, and then about 7 months of gestation, they'll begin their descent and into the testes. If they don't, it's called undescended testes. And unfortunately, surgery would be required to move the testes from the pelvic cavity into the scrotum. Otherwise, the body temp issue would occur and the testis would be non-functional. Okay, a little bit more. Sperm and fluid will travel through seminiferous tubules. And so these are the ducts I was talking about in tubules. So we have sperm that's made, and we'll get into spermatogenesis and spermiogenesis in a minute. But sperm's made, fluid is also added, And they'll travel from the seminiferous tubules to the straight tubules. And then there's this whole network of ducts called the rete testis. So here's the seminiferous tubules right here. Okay. And then the straight tubules are right here. That's a straight tubule. Let me put an arrow there. There's a straight tubule. You can see it's straight. You have the seminiferous and then the straight tubule. Not bad. And then there's this whole network right here, and that's called the rete testes. And or testis. And this is actually where the sperm will end up prior to entering the epididymis, and we'll get to the epididymis. From the rete testes, though, there is what's called an efferent duct. It's located right here's the efferent duct. You can see how it's located. It enters the epididymis, and once it's in the epididymis, there's various functions that occur, various things occur. But from the epididymis, we go to the next duct, and that next duct is the ductus deferens. Used to be called the vas deferens. No longer called that because it is a duct. It's not a vein, and vas means vein or vessel. Okay, couple clinical stuff. I like that. So I was talking about this before, the failure of the testes to descend. It actually has a name. It's called cryptochordism. And sometimes it's one testes, and sometimes it's both. So, again, it's a surgical fix near when the child's born. And sometimes if one of them doesn't descend and one does, sometimes they won't even do the surgery. Now, twisting of the testes results in what's called testicular torsion, extremely painful. The spermatic cord has some nerves, has vessels, nerves, the ducts, a whole bunch of things, and we'll talk about the spermatic cord in detail. But if that twists, it blocks the blood flow to the affected testes. And it is, like I said, extremely painful. And to save that testis, treatment has to be done immediately. And what they do is they go in surgically and untwist the testis, and then they'll put and attach it to the scrotum so it doesn't happen again. Because once it happens, or when it happens once, it's going to happen again. Okay, so let's start our conversation about how sperm is made. And so to do that, we have to talk about a couple of cells that are located in the testes. The first one is called the Sertoli cell. The official name is sustentacular cell. I always think sustentacular whenever I say that for some reason. But, and you can call it either. They used to be called just offhand the nurse cells. So you can have an idea by the care that it gives, these cells give to the growing sperm cells, why they ended up with that name. They're very large cells. I'm going to show you a picture. And they are embedded among all of the spermatogenic cells. And those spermatogenic cells are in different stages of development. And the sustentacular cells, or Sertoli cells, they actually have tight junctions between each other. And this is really important because it forms a blood-testis barrier, so there's no immune response against these sperm cells. This is really important because anytime we make changes to the number of chromosomes, and make changes to cells, the immune system will recognize it as foreign and therefore would attack. So that's why the blood testis barrier is so important. So a couple functions: nourishment of the spermatocytes, spermatids, and spermatozoa as they grow. Um, they mediate the effects of the testosterone as well as FSH on spermatogenesis, and again, we'll discuss that in a little more detail. They'll phagocytize excess spermatids or excess spermatid cytoplasm, actually, as development proceeds. Because as you're going to see, the very first spermatids and spermatocytes have a lot of cytoplasm, and it's the job of the Sertoli cell to remove that cytoplasm as the sperm grows. There's also control of movement of spermatogenic cells as they release the spermatozoa into the lumen of the seminiferous tubule, so responsible for assisting with the pushing of the sperm from the seminiferous tubules into the straight tubules. And then finally, they will secrete a transport fluid, as well as a specific hormone called inhibin. And again, when we talk about hormones, I'll go into that in more detail. All right, Leydig cells. Okay, we'll call them interstitial endocrinocytes. I learned them as Leydig, so forgive me for calling them that. But they're found in the spaces between adjacent seminiferous tubules. And their main job, is secretion of testosterone. Okay. So this is a great picture because this picture actually shows you the interstitial cells. So there's the interstitial cell there. And then these large Sertoli cells. Now, I'm going to put dots, and I'm going to show you, these are all sperm cells, the ones I'm ones I'm kind of marking. Those are all sperm cells. This is the nucleus right here of the sustentacular cells, or the Sertoli cells. And then you can see here, right in this area, that junction, the blood testis barrier tight junction. So I like this. We're going to look at this side of it shortly. Okay, let's start talking about spermatogenesis. And I have this in text format and in the next slide in picture format. It's basically the process of taking a diploid cell, right, and turning it into a haploid functional sperm. So we do start out with diploid spermatogonia, and those are considered the stem cells, and they undergo mitosis. And when they undergo mitosis, the two cells that result, one of them goes on to be just another stem cell, but the other is the one that goes on to develop into a spermatozoa. So once that cell, when the spermatogonia divide, then they become a diploid primary spermatocyte, or 2N, and that's just saying it's double, right, the chromosomes. So the diploid primary spermatocytes will undergo the first stage of meiosis, and that first stage causes it to become haploid. So it's half the number of chromosomes in these secondary spermatocytes. Now, from the secondary spermatocytes, those undergo meiosis too. And that's where we get haploid spermatocytes. And the reason why the name changes is because you have, let me just get my pen active, you end up having, right? Okay, that's supposed to be like an attachment right there. You have the chromosome, and then the chromosome will break up into individual chromatids. And so instead of calling the haploid cells, right, the spermatids chromatids, they call it spermatids, which I always think is kind of funny. Anyway, but the spermatids are connected to each other. So they're not mature yet. They're still connected. Their cytoplasm is all connected together. But then once they continue the growth process, they become spermatozoa. And that's the final stage. And when the spermatids mature into spermatozoa, we just call it sperm. And that whole idea of once the sperm is released from the sustentacular or Sertoli cell, that release of the sperm from its connection, that's called spermiation. Okay, so this is the slide that actually shows you the pictures and how it works. So we start out with the spermatogonium, right? That's the stem cell. It's 2N, meaning 46 chromosomes. And it divides, and one of the cells goes off. You can see in this area, one of the cells goes off to become another uh, stem cell. But the other becomes a primary spermatocyte. Still has 46 chromosomes. There's still 46. And 46 here. Okay. Now, the first part, right, this primary spermatocyte, it undergoes meiosis. And what it does in meiosis is it halves the number of chromosomes. Remember, at that point, the chromosomes are still kind of attached together like that. And so it takes meiosis 2 to separate those into individual chromatids. And so then we call it a spermatid, as I mentioned previously. And then finally you have the sperm cell spermatozoa. And that's the release, like this one right here, it's released. That's called spermiation. Okay, this is just another view of just the developing cells. So it's the same idea. You have the spermatogonium up here, and it either, once one of the divided cells becomes another spermatogonium, the other goes through the differentiation process. So from 2N to the primary spermatocyte, still 2N, right? Again, 2N makes 46 chromosomes. Undergoes meiosis 1. You have the secondary spermatocytes, and remember those secondary spermatocytes again, right, are those two chromosomes, but there's half of them. It takes meiosis 2 to divide these two cells. They're located here. They'll divide, and they'll create, so you end up with the two cells that have this. They're going to divide into individual chromatids, hence the name spermatid, and then finally into mature or more mature, well, not actually completely mature yet, but more mature sperm cells or spermatozoa. And then those are then released into the lumen of the seminiferous tubule. And remember, that's called spermiogenesis. All right, so what's the whole reason for sperm? Well, the goal and the design is so that they can reach and penetrate a secondary oocyte in the female in order to achieve fertilization and create a zygote. So sperm are produced at a rate of about 300 million per day. And once they're ejaculated, they'll last for up to 48 hours. They can fertilize an egg for up to 48 hours within the female reproductive tract. So looking at the sperm cell anatomy, we have the head, we have the tail. Okay. The head is where the 23 chromosomes reside, or the chromatids reside. And on the very tip here, you can see it's called the chromosome. It covers that head. And it's really interesting. A chromosome contains enzymes which help break away at the surroundings of the oocyte to allow the sperm to penetrate. The neck piece, you can see it right here. That contains centrioles, and those centrioles form microtubules, and that's what makes up the rest of the tail, and that's what allows the flagella to move and to allow the sperm to be motile. This middle piece right here, right, this contains a whole bunch of mitochondria. They make ATP for locomotion. Right? It takes a lot of ATP to move the tail back and forth for motility of the sperm. And so this whole middle piece is reserved and is just full of mitochondria. And then finally the principal piece, end piece, right? It makes up the tail. And again, that's a flagella. It's all for movement. All right, let's talk about the hormones that are involved. The hormones basically control testicular function. And at puberty, it starts out with gonadotropin releasing hormone, GnRH, that comes from the hypothalamus and stimulates cells in the anterior pituitary to produce two different hormones. The first is the luteinizing hormone, call it short LH, and this is what stimulates the cells in the testes, the Leydig cells, to produce testosterone, or the interstitial cells. Sorry, old habits. The second is follicular stimulating hormone, or FSH, and FSH is what supports the spermatogenesis and the making of the sperm. It stimulates that process. And then finally, I mentioned prior that inhibin is released by Sertoli or sustentacular cells. Inhibin actually inhibits FSH, and so it's a great regulator for spermatogenesis to increase or decrease the amount of sperm that's produced. One of the most important hormones in this whole process is testosterone. Um, Another name for testosterone, like um, that's even stronger, is dihydrotestosterone, DHT, and it's just a stronger version of testosterone. So we can think of them very similarly or the same. They produce a lot of effects. So one of the effects is prenatal development of the male, right? Without the testosterone, dihydrotestosterone, the fetus does not develop as a male. The development, of course, of male sexual characteristics, the penis, the testis, the ducts, glands, etc., as well as development of sexual function and stimulation of anabolism. And remember, anabolism is the building up, right? This is why it's a little bit easier for males to build muscle, right? Testosterone increases that anabolism. There is a negative feedback system, and that's what you're seeing on this particular slide, and it gets a little complicated. It's the control mechanism for testosterone. Um, I find it easiest if we start looking at it with the cells that are in the testis themselves. So we have the spermatogenic cells, or let's call them, right, They're right there, the sperm cells, let's just call them that are in the sustentacular cells. The sustentacular cells will secrete something called androgen binding protein, which is great because it binds the androgen, it binds the testosterone that's created by the interstitial cells or Leydig cells that are located right here. Okay, and then this is just showing you the testosterone. So there's already a mechanism in place that the interstitial cells or Leydig cells secrete testosterone, right? And then act on the sustentacular cells to increase spermatogenesis. Um, all right, so the negative feedback process. Remember the Sertoli cells secrete inhibin, and that inhibits the secretion of FSH, right? So remember that FSH stimulates spermatogenesis, so it controls spermatogenesis. So the FSH controlling spermatogenesis, you see here, it's green, it's coming down, controlling it, and then you have inhibin as your negative feedback mechanism to stop FSH from being secreted. Now, testosterone also feeds back. And testosterone feeds back on LH, okay, luteinizing hormone. Remember, luteinizing hormone increases the amount of testosterone produced. And it actually feeds back both on the anterior pituitary as well as the hypothalamus and will feed back on GnRH as well. Okay. So if you break it down, this picture actually is a great summary of how the hormones work. Just break it down into individual portions to make sense. Okay, let's talk about another structure, and that's the epididymis. I keep touching my nose, I don't know why. The comma-shaped organ. Yeah, okay, it looks kind of like a comma, I guess. It's on the posterior border of the testis. And so once spermatogenesis occurs, the sperm are transported out of the testes via efferent ducts into the epididymis. And that efferent ducts basically dump the sperm into the ductus epididymis. Okay. And these ducts are lined by stereocilia. And this is really where sperm do their final maturation, in a sense. There's some other maturation that occurs in the female reproductive tract, and we'll talk about that more when we talk about fertilization. But really, sperm maturation, the epididymis will store sperm, and they can remain in storage for, a while, and either they'll be reabsorbed or expelled, right? Degenerated, reabsorbed, or expelled. All right, here's a great picture of the epididymis, and you can see, I guess it looks like a comma. All right, there's your comma right there. I'm having too much fun with this. This first part is the head of the epididymis, and I put it in blue, all the anatomical structures of the epididymis that are larger. So you have a head, the head of the epididymis, you have the body, and then you have the tail. Okay, and then it's the tail portion that actually interacts with the ductus deferens. So the efferent duct and the ductus epididymis, I've shown you in red. So that kind of gives you an idea of the structure and of the tubules and how it works and the structure itself, overall, the head, the body, the tail of the epididymis. All right, the ductus deferens, or the vas deferens, this exits the tail of the epididymis, right? It sends through the spermatic cord into the pelvis. And it's really unique. It loops over, and you can see this in the lab on the models. It loops over the ureter, and passes over the side and down kind of the posterior surface of the urinary bladder. And one of the clinical correlations for the ductus deferens is a vasectomy. It should be a ductectomy because we no longer use vas deferens, but you know, old habits die hard. It's still called a vasectomy. And that's when they cut the ductus deferens in order to render the male infertile once um, that individual decides not to have any more children or have children. It's actually a very simple surgery, much easier than a female having a tubal ligation or their tubes tied. Okay, so finally we're going to talk about the spermatic cord. And we're not going to go into major detail about it, but it's important that you know what it contains. It ascends out of the scrotum, and it contains a whole bunch of things that support the testis. The ductus deferens, of course, which carries the sperm out. The testicular artery. Any of the veins, there's numerous ones that drain the testes. It has the nervous, the autonomic nervous system, and you're going to see why that's important shortly. There's lymphatic vessels, and of course our cremaster muscle is part of the spermatocord, and again that moves the scrotum up towards the body or down away from the pelvis, given the tip. Okay, then we have the ejaculatory duct, or ducts, because there's one on either side, and this arrives from the junction of the seminal vesicle, and we'll talk about what the vesicle does in a moment, but the seminal vesicle and the ampulla of the ductus deferens, and it forms together to form the ejaculatory duct. The function of these ducts are to eject spermatozoa into the prostatic urethra, and that's the urethra that we know goes through the prostate from the bladder. Now, the urethra, we learned during the urinary system, has 3 different portions, and remember that it's shared between reproductive as well as the urinary system. It will pass through the prostate gland. We have that passing right here. Then there's this intermediate area, basically passes through the pelvic floor. And then you have the spongy urethra that's in the penis itself. Okay. Sometimes, by the way, sometimes the intermediate is also called the membranous. Just FYI. I'll put both. Okay, those seminal vessels. These are considered accessory sex glands. And I'm going to talk about a couple of them and what they secrete. And it's important that you know what they secrete. So seminal vesicles secrete an alkaline. Remember, alkaline means basic. Very viscous fluid. It contains fructose, prostaglandins, and some clotting proteins. And the reason is that it's so basic is that it helps neutralize acid from the urine in the male urethra. It also, the vagina is slightly acidic, so it also helps neutralize that in the female reproductive tract. Now, the fructose is needed for all those mitochondria in the midpiece for ATP production. Prostaglandins help sperm motility and viability. And finally, there's something called seminogelin. Gelin? Seminogelin. Let's call it that. It's the main protein that causes coagulation of sperm after ejaculation. And you're going to see that the sperm, the contents of semen will coagulate and then will uncoagulate, I guess, after ejaculation as long as it's into the female reproductive tract. It's kind of fascinating. And all because of what is in the semen. Okay, next, the prostate gland. The prostate gland also contributes to semen, and it secretes a very milky, slightly acidic fluid. So it's a good thing we have the alkaline fluid from the seminal vesicles. But it also helps provide nutrients for sperm and ATP production by citric acid. It contains acid phosphatase, and again, contributing slightly acidic fluid. It also has some enzymes in it, and one of those enzymes that is used medically is prostate-specific antigens, PSA. And it's used, and this is becoming controversial about its use, but in the past it's been used to test males over the age of 50 if their PSA levels increased. It was maybe a sign there might be prostate cancer present. But it's been found by studies that maybe that's not really what's going on. So anyway, that's under investigation. Also secretes pepsinogen. Where have you heard that from? Digestive. It's crazy, right? A enzyme, a protein enzyme, or an enzyme that breaks down protein. Lysozymes, amylase, right? All of these things that we know of from the digestive tract actually are in semen. And then it secretes hyaluronidase. Say that 5 times. Um, and that's what liquefies the coagulated semen. So like I was saying, the coagulated semen from the seminal vesicles, that coagulation factor, is then liquefied by secretions from the prostate gland. All right, finally we have the bulbourethral glands. They used to be called the Cowper's glands, and they secrete mucus just for lubrication, and they also help neutralize acid as well. Okay, now that you know that what each of the glands end up producing and putting into the semen, let's talk about semen itself. It's a mixture of sperm and seminal fluid, and the volume of ejaculate is about 2.5 to 5 mils, with a crazy amount per mil, 50 to 150 million sperm. pH is between 7.2, 7.7. It contains all sorts of stuff. We already learned about that. Antibiotic, seminal plasmin, prostatic enzymes, coagulate and then liquefy. And the reason it coagulates and liquefy is to aid in its movement through the uterine cervix. Again, which we'll touch on in the female reproductive and during fertilization. Once ejaculated, the semen will coagulate within 5 minutes. And that's, of course, due to those clotting proteins from the seminal vesicles. But then after about 10 to 20 minutes, that's when the reliquefying happens from the proteolytic enzymes and the PSA. All of those enzymes from the prostate break down the clot, okay, and reliquefy. Okay, the penis itself. So the penis is supported by the fundiform and the suspensory ligaments. And it contains the urethra. I think you already know that. It's passageway for semen and urine. But internally, it's composed of 3 cylindrical masses. There's 2 corpora cavernosa, and 1 corpus spongiosum. And all 3 are considered erectile tissues. All 3 will fill with blood upon erection. It's important that you remember the number for the final exam, that there's 2 corpora cavernosa and only 1 corpus spongiosum. Also for the lab exam. Okay, externally, the penis consists of a roots, the body, and the glands. Covering the glands is a loosely fitting prepuce or foreskin, and this is often removed during circumcision. It's a surgical procedure. I have actually performed circumcisions during my pediatric rotations, and that's when the entire foreskin is removed. And a lot of times it's done for religious reasons, sometimes for hygienic reasons, and sometimes because it's the preference of the parents. There really isn't a consensus among physicians regarding whether circumcision is a positive or a good thing or whether it's a bad thing. It's really up to those factors that I mentioned before. Okay, so let's talk about erection and ejaculation. Erection occurs when there's an expansion of the blood sinuses in the corpora. And that happens because there's vasodilation of the arterioles in the erectile tissue, which are the corpora, the cavernosa, and the spongiosa. Um, and of course, this occurs under the influence of sexual excitement. So when a large amount of blood enters the tissues, right, there's these dilated blood sinuses in the erectile tissue that allow that blood to fill the penis and cause that erection. This is a parasympathetic reflex. And in med school, I'm sharing with you one of my mnemonics that I will never forget. It's controlled by the parasympathetic, so it's point. Right? Now, ejaculation is defined as a powerful release of semen and sperm, right, from the urethra to the exterior. This is a sympathetic reflex. So we always said shoot. So you have point for parasympathetic and shoot for sympathetic, and get kind of get the gist of how that mnemonic works. Um, there's several muscles, pelvic floor muscles that act to really force the semen out. That's the bulbospongiosus, the ischiocavernosus, superficial transverse perineal muscles, etc. Just know the muscles help force the semen out. Okay, so here's a picture of the anatomy of the penis. So we've talked about a lot of it. Note, here's the root of the penis, which contains the bulb and the crest of the penis. This is showing you the body. There's the corpus cavernosa here and here. The corpus spongiosum kind of is behind them based on this view, right? It's behind it. And then it's showing you the urethra, the spongy urethra. The area here is called the corona, okay? And then the glans penis, and this particular picture does show the foreskin that's covering the glans. All right, here's a cross section of the penis. I always say it looks kind of like a face. You can see it, I think, a little better in this view. The corpus cavernosa are on either side here. They make up the eyes with the deep artery of the penis, right? So that's the corpus cavernosum. On either side, there's two of them. And then much smaller is the corpus spongiosum. And that's where the urethra and the whole role of the corpus spongiosum is actually to maintain the urethra open during erection, so ejaculation can occur. So even though this is erectile tissue, it still will keep that urethral opening the spongy urethra open. And that kind of forms the mouth. All right, I have a weird imagination. Um, Over here is a really great picture of a cross-section of a penis of a cadaver. You can see the spaces within the corpus cavernosus that the blood can fill during erection. A little bit of less space. There's a few on here around the corpus spongiosum and around the urethra, but you can really see the spaces within the corpus cavernosa here. This picture, the very top, circling mall. Okay, this one actually has a square around it. This is where you have the deep dorsal vein that drains the blood. The dorsal arteries, dorsal artery on either side, arteries, I guess. And then there's a more superficial dorsal vein and fascia. Don't worry too much about the fascia. Oh, I guess we're at an end. So I've included good old Hank for your viewing pleasure. And please have a look at this particular one talking about the male reproductive system. And that's it for male reproduction. I'll be honest, the female reproductive system is a little bit more complicated, but we talk about LH and FSH again, and we'll lead up to, we'll finish that on Tuesday, leading up to fertilization and development, and even genetics. We are getting down to the end, and I am a little bummed I didn't get to see you today, but I'm kind of happy to be in my bathrobe. Anyway, if you have questions, please email me, text me. I don't know. The latest update I heard from Anza is that at 5 a.m. or actually, you're supposed to check tonight on the website, those of you that have Friday Lab, to see if Anza is open tomorrow. And they'll make the final call at 5 a.m. Okay, and so that'll be posted. And of course, I'll be up. It's my curse. And we'll also post a message to you. All right. Have a wonderful day and enjoy your afternoon. Stay safe. Make sure you don't do too many activities outside today. Thanks.